Hey everyone, welcome back to Daily Dose of Space. If you love real space news, cosmic mysteries, and the weirdest discoveries happening across the universe, this is the place to be. Today's story? A black hole that should not exist where it is, but does anyway. Let's jump in. Here's the quick version before we go deeper. Astronomers using the Very Large Array and data from several sky surveys found a 37,000 solar mass black hole sitting far away from the center of a dwarf galaxy located roughly 290 million light-years away. That's already weird. Black holes of this mass are normally found at galactic centers. But this one? It's off to the side alone, with no stars orbiting it. So, how did it get there? Did it merge with something? Was it kicked out of its home? Or is this evidence of a whole hidden population of wandering black holes? Let's break it down. The discovery: how a hidden monster was found. This discovery started with something astronomers call a radio excess, a patch of sky that was emitting far more radio energy than it should. At first, researchers assumed it might be a supernova remnant, a pulsar, or a bright star-forming region. But it didn't match any of those profiles. Instead, the signal looked like a compact, insanely energetic source. Exactly what you'd expect from matter being crushed and heated right before falling into a black hole. The next step was to check the location against optical surveys. And that's when things turned strange. The radio source did not align with the galaxy's core. It was offset, floating alone like a dark engine drifting through the outskirts. That's not where a black hole belongs, unless something violent happened. What is a wandering black hole? Black holes come in a few main types. Stellar mass black holes, created from collapsed stars. Supermassive black holes, millions or billions of solar masses. Intermediate mass black holes, the rare in-between class. The black hole discovered in this dwarf galaxy sits in the intermediate mass category, a class astronomers have been searching for decades. But what makes this one special is not its mass. It's the fact that it's not at the center of its galaxy. This means one of two things happened. Scenario 1, a galactic merger gone wrong. Two dwarf galaxies may have collided. Each had its own central black hole. When they merged, gravitational forces kicked one of the black holes out of the center, leaving it drifting through the new combined galaxy. This is called gravitational recoil, and it's powerful enough to launch a black hole at thousands of kilometers per second. Scenario 2, a black hole that ate too much. If a black hole feeds aggressively, consuming gas, dust, and stars, the uneven flow of material can actually give it a kick, slowly pushing it off-center over millions of years. Kind of like using a flamethrower as a jetpack, but on a cosmic scale. Either way, the result is the same: a giant, hungry black hole wandering without a home. Why this discovery is so important. Here's why astronomers are excited about this one. 1. It proves intermediate mass black holes really exist. These middleweight black holes are incredibly hard to find. They don't shine like quasars, and they're too massive to form from normal stars. Finding one, and especially one in the wild, helps confirm how black holes grow over cosmic time. 2. It suggests dwarf galaxies may hide more black holes. Dwarf galaxies are the most common type of galaxy in the universe, and many are too small or faint for us to see clearly. If even a fraction of them contain wandering or off-center black holes, then the total number of intermediate mass black holes might be far higher than predicted, possibly millions more. 3. It hints that rogue black holes could drift between stars. If black holes can be kicked out of dwarf galaxies, then some may get flung completely out of galaxies, drifting through intergalactic space. Imagine black holes drifting silently through the void. Invisible, undetectable. Unless they swallow something by accident, we already know of a few candidates in the Milky Way. This new discovery strengthens the case that rogue black holes may be common. Could a wandering black hole ever threaten Earth? Short answer: no. At least, not anytime soon. Space is huge. The distances between stars are unimaginably large. A wandering black hole passing close enough to disrupt our solar system is extremely unlikely. The last confirmed isolated black hole discovered via microlensing by Hubble in 2022 is thousands of light years away, and it's moving harmlessly through the Milky Way. This new one is hundreds of millions of light years away. But the discovery still matters because it changes our understanding of how many black holes the universe may hold and where they might be hiding. How we detect wandering black holes. Detecting an isolated or off-center black hole is insanely difficult because black holes don't emit light on their own. Astronomers rely on indirect clues. 1. Radio emissions from infalling material. Gas falling toward the black hole gets heated and accelerated, producing radio waves. This is how the new black hole was found. 2. X-rays. If the accretion disk is hot enough, it shines in X-ray wavelengths. 3. Gravitational lensing. If a black hole passes in front of a background star, its gravity bends the star's light, revealing the black hole's mass. 4. Disturbed stellar motion. Stars orbit strangely if a massive, invisible object is nearby. For this new discovery, it was radio plus positional offset that gave it away. That means many more wandering black holes could be out there, but too faint to detect. Why a dwarf galaxy is the perfect place to find one. Dwarf galaxies have lower gravity, fewer stars, weaker central binding forces. This makes them more susceptible to losing their central black hole if something big disturbs them, like a merger or a gravitational kick. Some astronomers even believe many dwarf galaxies have lost their black holes already, flinging them into deep space. This new detection supports that idea. The big question: how many more are out there? This find isn't just an isolated curiosity, it's a clue. A clue that the universe might be filled with thousands or even millions of unbound black holes, drifting silently through galaxies. Invisible, undetectable, waiting. If even 5% of dwarf galaxies have wandering black holes, the number jumps dramatically. And if some are ejected completely, the space between galaxies could be littered with rogue black holes we've never seen. Astronomers now want to perform broader radio surveys to search for more of these off-center monsters. This is likely the first of many. This discovery shows just how dynamic and chaotic the universe really is. Galaxies collide, black holes get kicked around, and entire cosmic structures reshape themselves over billions of years. And every time we look deeper, we find something that changes everything. If you enjoyed today's dive into this wandering black hole, make sure to subscribe for your daily dose of space. And let me know in the comments, do you think there are rogue black holes drifting through the Milky Way right now?